My name is Kaspar Althoefer. I'm Professor of Robotics Engineering at Queen Mary University of London. And I'm also the Director of the Center for Advanced Robotics at Queen Mary. We are really making a difference compared to what has been researched in many other places. Our robotic devices are based on fabric, so they are actually inflatable structures. And these are effectively long extendable or extending tentacles that can be pushed through very narrow openings and be moved into these difficult environments. And they have a number of advantages. They are made of very um, thin material, and in this way they are very lightweight and can extend very far. But another big advantage we can see is that they don't contribute a lot to the radioactive waste, because often when you send a robotic device or any kind of device in these environments, they become radioactive themselves and have to be discarded, and that adds to the mountain of radioactive waste. So we see there a great advantage there. And maybe a few points on how that works. So imagine you have a sleeve made of airtight fabric, and that when air is pumped into it, folds out at the tip. So it extends at the tip like a sleeve folding inside out into the environment. And we can reach far and then deliver sensors there or carry out manipulation tasks. I would like to add another advantage of these devices. They are the main actuator, so the compressor that pushes the air inside is positioned remotely, so outside that environment. And that means we actually don't have any electronics on board or very fragile components. And we believe that with such an approach, we create robotic devices that can last much longer in these environments, in these very highly radioactive environments, than other robotic systems. We are looking at sensors that can actually give us information about our robot arm, about its position, about the interaction with the environment. And it's really paramount in this context that these robots go go in there without disturbing the place too much. So we don't want to push up radioactive dust too much. And here, our sensors will allow us, first of all, to tell us where the robot is, but also tell us on how much force we apply to the environment, and we try to keep that to a minimum. These sensors are based on optic fibers, so we have a lot of expertise in that area. And so effectively we use light and measure now by the means of light the interaction with those robotic devices and the environment.